Welcome to Saucy Math. This is a video about factoring. It's one in a series of videos that I'm doing of factoring with all the different factoring methods that we have. And this one's going to be about factoring a quadratic trinomial in the case where a equals 1. All right, so what that means, a equals 1, when you're dealing with a quadratic expression, the a refers to the leading coefficient, right? The number that's in front of the x squared. All right, so in this case, it's just 1x squared. Now, we don't actually write the 1 there. So whenever you see a quadratic expression like this that just has an x squared without a number in front of it, this is the method you can use to factor something like that. And of all the factoring methods, this one is maybe the easiest one to use. It's almost like you're playing a game with the numbers. You're just trying to figure out a couple different numbers that are going to fit a certain way. All right? And the way it's going to work is I'm going to take my expression x squared plus 12x plus 20, and I'm going to eventually factor that into two factors, right? So I'm going to set up two parentheses there, and then I just have to fill in the parentheses, right? So the x squared, if I think about this, factoring something like this is kind of like doing the FOIL method in reverse, right? So in order to end up with an x squared, if I multiply two parentheses together, when I multiply the first terms, right, this one times this one, have to multiply together to equal x squared. Well, in order to get x squared, I'm going to have to multiply x times x. All right, so I can fill in my first parentheses if this is just x squared. Remember, if there's a number in front of the x squared, these are not just going to be x and x. There'll be like numbers maybe in front of the x. All right, but in this case, I can just go ahead and put the x in the front of each parentheses because that's what it's going to have to be. All right, and then if you think again of the FOIL method, when you multiply these two binomials together, the last terms, this number times this number, have to multiply together to equal this 20 that we have up here. Right, so the two numbers that I use to fill out my parentheses have to multiply together to equal 20. But there's lots of numbers that can multiply to equal 20. And if I kind of make a list of them over here, it could be 1 times 20, it can be 2 times 10, it can be 4 times 5. All right, so those are all the possibilities of numbers that I can use to multiply to 20. So I can't just pick any one of these to fill in this parentheses. Right? I can't just do 1 or 20 or 2 or 10 or 4 and 5. Only one of those is actually going to work. And the way we can tell which one is going to work is by using this middle term here to kind of check it out. Right? Because remember, if we do the FOIL method, right, the first terms multiply together, x times x is going to give us x squared. The last terms, those two numbers, are going to multiply to equal 20. But when we do the inner and the outer terms, right, the inner terms is going to be some number times x. The outer terms is going to be x times that other number that we choose. And when we add those together, they have to add up to equal this 12x that we have in the middle. All right, so I need two numbers that multiply to equal 20 and that add up to equal 12. Right, because when I FOIL and I do the inner and the outer terms and I combine those like terms together, they're going to add up to equal this 12x that we have here. All right, so now we look back at our list of numbers that multiply to equal 20, and we've got to figure out, well, which one of these, if I add them together, is going to add up to 12. Right? And if you are any way competent with doing addition, it's pretty obvious that it's going to be 2 plus 10 adds up to equal 12. Right, so the numbers I'm going to use in my factors there are going to be a plus 2 and a plus 10. Right? And the order you write these, if you wrote x plus 10 and then x plus 2, that doesn't matter. Right? As long as you have the correct numbers in the correct spots, you're going to have it. Right? So that's our factoring of x squared minus 12x plus 20. Right? The short way to do it is, if there's just a no coefficient in front of the x squared, right, it's just a 1x squared, look for two numbers that multiply to equal 20 and add up to 12. And some of you can look at that and just do it in your head without having to make this list over here. And if you can do that, skip doing this list, just go ahead and write down the numbers. Right? There's not that many possibilities of numbers that multiply to 20, so you could probably just do in your head, well, it's not 1 times 20 because that doesn't add up to 12. It's not 4 times 5 because that doesn't add up to 12. But 2 times 10, those numbers add up to 12, so I have 2 and 10. And then you're done with the factoring. Right? And just like any other type of factoring, if you were to FOIL this back together and multiply it all out, it should give you the exact same expression that you started with up here. And if it doesn't, then you messed up and you can go fix it. All right, so let's look at one more example, which I would say is more complicated, but it really doesn't get much more complicated when you're doing this type of factoring. Where it gets more complicated is when you start having numbers in front of the x squared, right? But that'll be on another video where I kind of go in more detail about how to do something like that. Right, so we have here x squared minus 5x minus 24. Right, what's different about this one from the last one is that now we have some minuses in there, some negative numbers. Right, so all that means is we just have to be a little bit more careful when we choose our numbers to make sure that all the signs match up. Right, but the approach we take is going to be the same. Right, so the x squared I split up into x times x. This minus 24, I'm going to split up into the two numbers that go here. So two numbers that multiply to equal negative 24. But those two numbers also have to add up to equal the number in the middle, which is a negative 5. Right? And the negatives there are important. Right? So it's not just 5, it's minus 5. So I'm looking for numbers that add up to a negative 5. All right, so let's start by listing the numbers that multiply to 24. It can be 1 times 24, 2 times 12, 3 times 8, and 4 times 6. And the way I did that is just start with 1. It's 1 times 24 to get 24. Then I try 2. 2 times 12 will give me 24, and then 3, 4. 5 isn't going to work. And then I already have 6 on the list, so that's when I know that I'm done. So just kind of go in order, try each number dividing into 24 to get that complete list there. All right, now, will any of these numbers add up to negative 5? Well, not the way I have them written here, but remember, these numbers have to multiply to equal negative 24, which means one of these numbers in each pair would have to be a negative in order for the product to be a negative 24. So if I make one of these numbers a negative, can I somehow add up to a negative 5? And you may be able to see, if I make that a negative 8, right, negative 8 plus 3 equals negative 5. And so those are going to be the two numbers that we want to use. All right, so when I go to my parentheses, x minus 8 and then positive 3, so x plus 3. And again, it doesn't matter. If you write x plus 3 and then x minus 8, it's the same difference. So that's our factoring of x squared minus 5x minus 24. All right, so when you're factoring these trinomials where there's no coefficient in front of the x squared, it's just a 1x squared, like I said, it's almost like you're playing a game with the numbers, just trying to figure out which numbers fit. And if you're really good at manipulating numbers in your head, these are pretty easy to do, especially in comparison to some other ones, which we'll look at in another video. All right, so check out my other videos on factoring to see some of those more difficult types.